Greetings aspirants, hope you are doing well. Welcome to another video of CC concepts from the subject Science and Technology, and today we'll be seeing about the properties of nanomaterials. Now, what are nanomaterials? Nanomaterials are those materials which are made of nanoparticles. You have to know that these particles are of the size of 1 into 10 power minus 9 meters, which is 1 billionth of a meter, Now, there are two important reasons for the special properties of these nanomaterials. The first one being increased surface area, and the second one being quantum effects. Now let us see how the properties of the nanomaterials are significant. The first one, as I told you, the nanomaterials are going to have increased surface area. The surface area of nanomaterials are generally substantially high compared to the bulk materials, because as we divide the materials, as we keep cutting on the materials, the surface area is going to increase. I have explained this concept in one of the previous videos. You can watch it. And this property is associated with all the nanomaterials because we are going to cut the materials, right? Now, coming to the second property. The second property is the magnetism. The point here is that if a material is magnetic at the macroscopic level, it might be non-magnetic at the microscopic level or at the nano level. Okay, so the magnetic behavior of the elements can change at the nanoscale. A non-magnetic element can act as magnetic at the nano level, at the nanoscale level. Now, coming to the next property, quantum effects. As I have told you, in the bulk material, most of the classical physics or the classical mechanics plays role. But when we are talking about the atoms at the nanoscale, which are the size of just 4 to 5 atoms, then quantum effects come to play a major role than the classical science, right? So the quantum effects are more pronounced at the nanoscale level. However, the size at which these effects appear strongly depends upon the nature of the semiconductor material which we are using, right? Now, talking about the next part, nanomaterials are going to have high electrical and thermal conductivity. According to the nature of the material, extraordinary properties can be seen at the nanoscale level compared to their bulk counterparts. For example, graphene, which is made from its bulk part, graphite. You can see, we know that graphene is one of the strongest materials, right? So this is one such example for the enhanced thermal and electrical conductivity. Now, they also exhibit excellent mechanical properties. They also exhibit excellent mechanical properties compared to the bulk counterparts. So nanomaterials exhibit excellent mechanical properties that are absent in their macroscopic counterparts. Now, coming to the last part, they are very catalytic. They are highly reactive in nature because we are talking about the properties, or we are talking about the materials at the nanoscale, which is where the size is very small, and just by small changes, we are going to get significant changes at the reaction level, right? So 2D sheets of various nanomaterials have provided the opportunity for the good dispersion of nanoparticles of active catalyst, enhancing the catalyst performance very strongly or very substantially. And also, recently catalysts have been atomically dispersed on 2D sheets of nanomaterials to boost their performance. So we have seen what are the significant properties or the significant changes which you can observe in the nanomaterials compared to the bulk parts. We'll be back again with another video. Thank you.